Okay, so what we are going to cover today is we will start with some of the introduction of uh, processes available in the SDFS component and also beyond yet another resource negotiator component, right? So once we give basic understanding about what it is, then we will get into the installation. For installation, so I'm going to initially we will set up uh, the virtual machine on our local laptop, and we'll install the Hadoop and uh, which is a MapReduce and Yarn component. Then later we will go to the cloud. When we go to AWS cloud, we will use the EMR cluster. So for learning all the concepts, we'll use the local VM. So once we are familiar within 1 or 2 weeks, after 2 weeks, so we'll actually start exploring the EMR part, right? Do you have any question on that? Um, and also, either if you want to parallelly start installation on your machine, you can actually follow up. Or if you want to do offline, also I'm fine with that. Anything I'm okay. So
What is the configuration required? Is it 4 GB is fine or we need more?
4 GB may not be fine.
Mhm.
At least 8 GB is the minimum. 4 GB
Okay,
you can
okay,
try, but it will be like it will be very slow. So it's very at least you get
okay.
just for practice you can try, but it's very difficult to work. So rather we will do so when we start AWS, you can create our free trial account there, and we can just try.
Yeah, yeah, yeah.
So others, do you have at least desktop or laptop with 8 GB configuration of RAM? Okay, okay, Naveen. Just give me 1 minute. Hello Shivam, good morning. I'll share my screen. Just let me know you're able to see my screen. Okay, so anyway, I'm recording it. People who join late can actually go through the video and follow up. Okay, so now before we start the installation, right? We'll go to on the installation of Hadoop. Before we start Hadoop installation, what we'll do is I will stop this. Yeah. Okay, so just I think everybody knows about the Oracle VirtualBox software, right? So basically, it is a software used for creating a virtual machine on your local desktop or in laptop, right? So basically, if you have a requirement to create a multiple version operating system on your machine, so you can use the Oracle VirtualBox. Yeah, it's kind of virtualization software, right? So it is free. Okay, so there is other virtualization software like VMware, which are commercial one. Okay, so if you want to download this, sorry, you can go to Oracle, type Oracle VirtualBox. This is the Oracle VirtualBox.org is the website. You can download the latest version of Oracle VirtualBox, and you can install. So it will be more of um, uh, downloading the exe and uh, installing just click on next, and you can just to do the installation. So once you install, so you will find this page, and initially probably these VMs will not be there. You can actually click on a new to create a new VM. Just I'm sorry, I just got one message. Okay, so you will get this page, this window where you can go and create a virtual machines. What we'll do is we'll just create one, click on new. It'll actually ask you to enter the virtual machine name. Okay, so I'll just say Hadoop, then Spark VM. Okay, so I will say like that. Okay, I'll say data making VM. Why I say? Because I have a set of commands which I prepared. So I just use the same name so that I just reuse the commands. Okay, I'll just say data making VM. You can give whatever name you want, and it is going to save my virtual machine on this location, right? So instead, I will use the different location because my C colon is already filled up. So I will use the D colon location. I just create um, data making training. Yeah, I will use this location. Okay, so choose others. I'll go here. Okay, and also I will provide. So this location it is going to create the VM. Now you need to choose what type of operating system you want to install. So for our Hadoop installation, we will be using the Linux flavor of operating system, uh, Ubuntu. So you choose Linux here, and in the version, you just go and choose the Ubuntu 64-bit, right? And you can choose the memory you want to allocate. So I just I have actually 16 GB of RAM laptop. I just use of 8192. So you can choose based on your your local machine um, RAM, you can choose allocate. Just start with the off of your laptop memory. So how it is the VM is performing. If it is slow, you can just increase little bit, or you can, if it is fine, you can actually based on your local usage, you can just change accordingly. This can be changed later also. The RAM memory. No need to worry about it, and then continue with this hard disk. You can just choose create a virtual hard disk now. Okay, and you can choose here the it's going to create on this location, and the hard disk, right, basically the file size you can create. This give try to give uh, more space, because once you create a virtual machine, increasing the hard disk, sorry, virtual machine size in terms of storage, right, it is very difficult. So just to give as much as possible, because the changing the virtual machine sizes in terms of storage is a little difficult. At least to I'm not a kind of the system admin guy, so it's I felt very difficult to do that. So starting itself, you allocate at least 50 GB, or probably 100 GB based on your disk availability, and you choose okay, again I'm saying, please interrupt me whenever you have any doubt. Okay, so probably every topic I'll just stop and ask for question, but if you feel that you have some question, you just stop me and ask me. Okay, I hope that's fine for everyone, right? Okay, so
Yes.
yeah, thanks. So then we'll choose a hard disk file type as VDI, virtual box disk image, and here dynamically allocate, and then I'll say create. So you see there is a virtual machine is created. That means we just created here. So we have to go and install our operating system. Now go to click on, you will, if you have multiple one, you just click on the respective one, and click on settings. Okay, now we need to go to the there is a general tab. You see basics, advanced, other stuff. Now go to the system, where you can actually change the RAM. So this can be changed anytime during whenever you want to change your RAM configuration. And display is fine. Come to storage section and click on this. You see there's a controller and a controller IDE and controller setup. Click on this controller IDE. Click on this empty option, and in the right side you see there is a the disk icon. Here you have to choose your operating system image file. So yesterday I pinged you in the chat, probably people who are in the group, I just chat the given you the link to download your Ubuntu desktop ISO file. Okay, so mine I already downloaded. I'll just if you already downloaded, you can also just use this. Please let me know if you're somebody is doing in online, so that I'll go little slow. Or if you want to do offline, I'll just go as per my pace. All right. So I'll just go to D colon. I have software installer. I have it here. Or okay, let me check where did I have it. I kept somewhere. Hmm, Just give me a minute. I don't know where did I kept the CSV file. Okay, so that's where you need to choose your ISO file, and then actually there will be instruction to install our operating system. Okay, so just give me 1 minute. It should be somewhere. Okay, so it is in D: workshop Ubuntu. I'll go here, go to again data making VM, and then I go to settings. I go to the storage section, click on this empty option in the controller IDE, and uh, choose the disk file. Okay, and navigate to my file location, which is in D column. Okay, you choose this ISO file and say OK. Okay, so you just make sure it is actually chosen in the storage section. Now we can start it. So basically, when we start this VM, it is going to boot up this ISO file and start the installation. Say continue. So start. I'll just maximize this window. So this OS installation will take some time. So that's the reason I just started, so that we can go and discuss about uh, the SDFS and MapReduce processes. So we'll just do few steps here, and then it is going to take some 10 minutes. Okay. So I started. Did I start something else? Not really this. Okay, so I did something different. Okay, go to settings. I choose on the other CSO file like this. Choose the current ISO, the operating system ISO file. So it is going to show you the Ubuntu installation options. So based on your system configuration, your VM will perform either fast or slow. Okay, so the Ubuntu is getting boot up. This is for first time. Just you have to bear with. We have to wait for the things to happen. Later, once you install a VM, then it's going to be faster. So again, it's based on your system configuration. So I will start Ubuntu installation. So it is going to ask me the time zone and as well as the keyboard layout. Just choose whatever the option you want. I'll just go English USA and continue. and so it's ask you to go with the normal installation and minimal installation. I'll go with normal installation, and by default this option will be checked. Download updates while installing Ubuntu, and you see there is a other option which says install third-party software for graphics and Wi-Fi hardware and additional media formats. Just check this so that you can use the Wi-Fi options which you use in a laptop inside your VM. Very useful to download your data sets from internet and exchange your files. So continue. So with that option, you just check that. If by default it will be unchecked, just check that and continue. Distribute. Okay, and it will ask you whether to erase the disk and install Ubuntu. This is not our local disk. Basically, the VM space you want to erase and start Ubuntu. You just continue with that. Say install now and continue. So time zone, I just choose India, Kolkata. For me, this is the time zone. You can choose as per your time zone. Now, this is a place where you can actually create users for your uh, operating system or Ubuntu operating system. So what I'll do is I just create data making, and I will give my computer name as data making VM. This is just whatever name you can give. As I mentioned, for the simplicity and the commands which I prepared, I'm just using my computer host name as data making VM and username is data making. And password you can set whatever you like. I'll just set data making. And when you log in, when you start VM and log in, do you want to every time do you want a prompt for password to enter, or you can just choose login automatically? I'll just continue. So okay, so this step is going to take at least 10 minutes. Meanwhile, we will discuss about the SDFS processes, right? So we saw SDFS, we discussed about SDFS, which is the distributed storage component. So this has different processes. Okay, so starting from a name node, there is a process called name node. When so people actually name this. They call it as name node is a process or daemon or whatever. Both are all are same. Basically, it's kind of if you want to tell in layman term, it's basically a Java program running on background and doing certain activities. So this is the name node process. What it does is it basically captures the storage metadata of your storage related things. So it actually manages metadata of your HDFS, metadata of your HDFS files or directories and storage related information. Storage related metrics. Okay, so basically it holds metadata about your HDFS. Okay, so then there is a one more process called a data node. Okay, which stores your actual blocks. stores the data, which is actually a blocks. So basically, in our SDFS, our data or our files are stored as a blocks, right? So the data node is a process which stores actual blocks. Name node will not store any data; only the metadata will be stored, right? Uh, Somebody have any question? All right. So there is one more process called a secondary name node. Okay, what it does is kind of uh, process which keeps tracking of your name node. So basically, it takes periodic backup of your name node, period, backup of sorry, periodic backup of your name node. So this is to support if suppose your name node is having some issue and there is a outage on your name node process. So then you can actually, if you want to restore the previous state, you can go and take the previous state from the secondary name node and you can restore it. So by default, I think every 1 hour it takes the every 1 hour the it takes the periodic backup of your name node by default. Okay, so let's see STFS beyond discussion. Okay, so this is the three process which is running on your STFS. Okay, so name node is for basically metadata about your files and directories are available in the STFS, and it's going to hold your all your block information. Right, when we say metadata, it's about where your blocks are stored in your different nodes. Okay, so if the link closes, please use the same link and join back. Okay, so when you so this name node is entire. It's not respect to single node. So entire clusters SDFS metadata is stored in the name node. Similarly, this is a master process. SDFS is a master. Sorry, name node is a master process. Yes, the master slave architecture, right? Some process has to do the master activities. The slave data node is a slave process. Okay, basically because that actually stores your data, and secondary name node also master process because it just has the metadata of name node. Okay, but it's not doing any activities, just takes the periodic backup of your name node. Okay, this is all the name node process, and it does respective activities. Now this is storage aspects we saw, right? So when we go to the MapReduce, like the computation aspects, I have to introduce you, at least I give you a short. Uh, so I told you yesterday there was different Hadoop versions, right? So initially it was Hadoop 1 was introduced.
Pari,
Um,
can you just go back to the previous diagram once?
yeah, yeah, sure, I'll do that. Yes, Hadoop 1 versus yes. You're able to see the screen. The other
Yeah, yeah. I got it. Yeah, you can carry on. I just wanted I want to see something. Yeah,
sure.
thank you.
Yeah, no problem. Yeah. So now coming back to so before we discuss about I'm going to discuss about yarn. Why this yarn has came? I'll just tell you that why this yarn component has come. We will discuss about why this. So in Hadoop 1, right? So there was again, when I say Hadoop, basically the SDFS and MapReduce. So we had a SDFS component and we had a MapReduce component. So SDFS, we had this same name node and data node, and we had a secondary name node. Okay. Uh, so it was these three processes was there, and it was doing this activities. In the with respect to this is for SDFS. So when in the MapReduce, we had a process. So in the MapReduce, we have a process like job tracker. There was a process called a job tracker, and there was a process called task tracker. Okay, so what is the role or probably the uh, what actually job tracker does or its role is to actually the MapReduce job will be submitted to the job tracker. So it takes your job, okay, and it schedules your job on your cluster, okay, scheduling. It does scheduling, okay, and also it goes and monitors your once the job is received from the client, the job client, and it schedules your job on your cluster, and it goes and monitors your jobs. If the when you say scheduling job on a cluster, it is going to do is going to run as a task, right? The job will be converted as a map and reduce task. Okay, so we go little deeper into the map reduce. I'll tell you in detail. So what is map task does, what is the reduce task does. Basically in a Hadoop MapReduce, or when we go to Spark, so your the when you submit a job, the underlying the final unit will be task, which does some operations, right? So this here you will have a task associated to the job. So if some of the task is failing, so it has to track, and then it has to reschedule the task to run retry the same task. So all these activities will be done by the job tracker in the Hadoop 1 version. Um, Scheduling, and then tracking of your um, tracking of your nodes resources. Okay, so other means the nodes resources. When I say resources, more of the RAM and CPU set. All this activity the job tracker does, and the task tracker process, it just does only the computation. So the job tracker will actually take a job and then shifts that job to the task tracker, and ask task tracker to run the task, right? Task will be running. Okay, the map task and reduce task will be, so the map task and reduce task will be running here. Okay, this was the architecture in MapReduce one. There was a problem when the people started using building a cluster, bigger cluster, right? So if the number of jobs are getting growing, so the job tracker process was not handling. So they mentioned like um, um, there is no like a specific cluster size on which the job tracker start breaking very frequently, and something like that. But generally they say it's in bigger cluster, and if you have a workload, more jobs are there, the job tracker start failing very frequently, because it has to done many activities. like a job scheduling part, job monitoring part, and tracking of resources in cluster. So it's become a single point of failure, SOP. There is a just terminology called SOP, single point of failure. So this process become difficult to maintain in the cluster. So that's a reason. Okay, they want to split this when it comes to processing framework. They want to split this processing part separately and the managing the resources and the scheduling part separately. That's the reason they introduced the new component called yarn, yet another resource negotiator. Okay, this was developed by the company called Atonworks. Now it's actually merged with the Cloudera. Okay, so what are the things Yarn was doing? We will just go and check that. But this was the earlier architecture of Hadoop one, means the different process used in the Hadoop one. And here also in Hadoop one also, if you take about the storage part, the process which respect to HDFS, the uh, name node also single point of failure. Okay, so to handle this, they supported high availability. That means you can have a few more master process, like name node can be configured into multiple nodes, and if one can be active, other can be standby. If active name node goes down, the one of the standby name node can come up and serve the request of storage related activities. That was introduced in the Hadoop 2 version. Okay, so we have only 1 minute left. We'll just close this session and please rejoin with the same link. Okay, we'll discuss Hadoop 2 and Yarn. I'll just stopping this. Please use the same link and rejoin.
Okay.